Assalamu alaikum. My name is Ariba Iqbal and today I will be discussing about the topic representation of graphs in analysis of algorithms with my group member Omina Saklan. What are graphs? Graphs are powerful data structures which are used to model relationships between objects. They consist of edges which are the connections and nodes which are also known as vertices. In real life they are used in wide areas like networking, social media, pathfinding, and Facebook connections. Types of graphs. There are various types of graphs like directed and undirected graphs, weighted and unweighted graphs, cyclic and acyclic graphs. Why graph representation matters? Graph affects the time and space complexity of the algorithms. They help in implementations of the algorithms like BFS, DFS, Digestra, and Kruskals. They influences their ease of implementations. That's why graphs are very important in our real lives. Graph representation techniques. There are two main types of graph representations, which are the adjacency matrix and the second one is the adjacency list. What is adjacency matrix? Basically, it is a 2D array which is used to represent a graph. If a node has an edge between them, there is an edge between two nodes, then that corresponding cell will be marked as 1, otherwise it will be 0. It is great for dense graphs having a space complexity of big of p squares. In the given example, we have a graph as there is no self loops on it, so we will mark the diagonals as 0. A having connection with B, C and D, so we have marked 1 at their place. B has connection with C and D, A and D, so we have write 1 at the place of A and D. C also has connection with A and D. D having connection with A, B and C, so we have written 3, 1 and 1, 0 in it. In the same way, adjacency list stores each vertex with a list of its adjacent vertices. It is implemented using an array. It is efficient for space sparse graphs having space complexity big of V plus E. Here we have an adjacency list of the same graph which we have discussed earlier. Its adjacency list will be like A have three nodes in its corresponding B, C, and D. So we will write B, C, and D. B has two nodes A and D. C has two nodes A and D has three nodes A, B, and C. Now we will discuss about impact on algorithms. Adjacency list is efficient for BFS and DFS. Adjacency list with priority queue is efficient for Digestra algorithms, while Kruskal algorithms requires an H list for its implementation, while Prim's algorithm depends on its density. It can use either a list or matrix. If it is dense, then it will use matrix, otherwise it will use adjacency list. Choosing the right representations. It depends upon the graph. If the graph is a sparse, then we will use adjacency list. If the graph is dense, then we will use adjacency matrix. Adjacency matrix is also used for H lookups. And the algorithms like Kruskal algorithms, we will use HList for sorting edges. Thank you so much for listening. And now my second group member, Momina Saklan, will continue.
I am Momina Saklan and I will continue the presentation from where my partner Ariba Iqbal left off. She explained the graph representations. Now, let's dive into one of the most important algorithms that work on graphs, breadth first search, which is also called BFS. Now, I will explain one of the most important graph algorithms, BFS. What is BFS? BFS is used to traverse or go through all the nodes in a graph. It works level by level, first visiting the starting node, then all of its neighbors, then their neighbors, and so on. How does it work? BFS uses a queue, which follows the FIFO rule, first in, first out. It is best for finding the shortest path in unweighted graphs, which means graphs where all edges have the same cost or no weights. Its best representation is BFS works efficiently with the agency list format. Let's break it down more simply. BFS visits all nodes at the current level before moving to the next level. It uses a queue to keep track of which node to visit next. It also keeps a visited list so it doesn't repeat nodes. What are its use cases? Great for solving shortest path problems used in maps, network, broadcast, friend recommendations, etc. Let's understand the BFS using this graph shown as an urgency list. We will start from node A and explore step by step. Start from A. Visit, now we see visited nodes. There is no visited nodes yet. So in Q we will write A. Now we visit A. Mark A as visited and A's neighbor B and C go into the queue and we will write B and C. Now we visit B from the queue and in the visited we will write AB. B's neighbor C is already in the queue so we don't add it again. Q becomes CC but we ignore the duplicate. Now visit C. Visited now in visited we write A B C. C's neighbor D and E are added to the queue. New queue becomes C D E. Next C comes up again but it's already visited so we skip it. Now we visit D. Visited nodes are A, B, C, D. D's neighbor is already in the queue so we don't add it again. Q becomes E and E. In the final steps now we visit E. In the visited, we will write A, B, C, D, E. E's neighbor F is added to the queue, E and F. Visit E again, which is already visited, so skip it. Then visit F. In the visited nodes, we will write A, B, C, D, E, F. No new neighbors. Q is now empty, BFS is complete. Final traversal order A, B, C, D, E, F. What does it mean? We started at A, then visited its neighbor B and C, then moved to D and E, and finally reached F. This is the final output. To summarize, BFS is a very useful algorithm for exploring graphs step by step. It works best on unweighted graphs and helpful for finding shortest path. It uses a queue to keep track of what to visit next. We saw how it visits each node only once and avoids repetition using a visited list. Thank you so much for listening.